you. I think I'm audible, and I'll be sharing my screen right now. Yeah, hope it is visible. Actually, we are on that last time. Yesterday's language and like our classified image that we have done yesterday. Hope all of you have tried it yesterday. And if you have any such kind of doubts or something, then we'll definitely solve in this session after the accuracy assessment. Okay, so now we'll go to the process of accuracy assessment. So basically, what accuracy assessment means that, so this LULC classification that we have done is a kind of a automation process, or else you could say that after the training, I think someone's mic is on, so please switch it off. Uh, so like, hello.
Yeah, go ahead, Anish, go ahead.
Okay. So like, we have trained some sites yesterday. I hope you remember about it. We have trained some regions, and we have classified this LULC. Hope you remember that we have created some ROI, region of interest, polygons from this water body, then vegetation built up, and open land. So likewise, we have created some training samples, and like yesterday we have taken only 50 to 60 samples from this area, but that was also in a very fast manner that I have demonstrated. So then after that, the system by itself mm, classified the image so that we need to check whether all these processes or the result that we have got is how much accurate is the result. Okay, so the LULC that we have created right now in front of your screen is done through a bit kind of a prediction. It's not actually the prediction, but I'm using in the general term. Don't think about like the data analytics concepts. It's not that kind of a prediction, but we have uh, predicted it in a sense with the help of the training samples. The system has modeled it, or it has just with the help of these training samples, it has classified the regions with the similar spectral signatures into a same group. Okay, so or it classified the spectral signatures that we have trained into a similar group. It's kind of a classification. Okay, so now we cannot simply just think that this is all correct and this is all the results. But what we have to do is that we have to check about the accuracy. Again, the accuracy in a sense means we have to check with real world whether if it is right, whether if it is wrong, or how much accurate it is, whether the water body that is the region which is classified as a water body, or the pixel which is classified as water body in this classified image, means the LULC is actually water body in the real world. So that is the check that we are gonna do. Okay, so that is basically accuracy assessment. Okay, the classified image, how much accurate the classified image is, and whether the results are acceptable in a general standard. So that is what accuracy assessment is doing. Okay, so uh, so basically for comparing a result or understanding about the accuracy of a what to say accuracy of a device or accuracy of anything, two things you need is that first one, you must have the result. Okay, first thing is like you must have the result, or here we'll say that it's the LULC or the classified image. Okay, so what actually is needed secondly is a reference data. A reference data. So what actually this reference data is, sometimes you will say in your domains or something like ground truth. Okay, you will say that ground truth, or like, or in what all things you know about, like the data that you have taken from the ground. Okay, that doesn't mean that you have gone to ground and taken that value, but it's actually the real data which is there, the real data in the sense, if I am telling like this is a processed Google Earth image or a Google map that act as a base layer in this QGIS. From here you can see that this region is water body. Okay, so this region is water body. So this is the ground truth. Okay, this is the ground truth or this is the reference. Okay, okay. Here it is a water body is present. So when you come to here you can see that okay, it is a building. So this is a built-up. So this is the ground truth at this point. Okay. So when you come here, you could see okay, this is an open ground. Okay, so this is the ground truth or the reference data. So when you come here somewhere else, let's say at this point, yeah, it is vegetation. Okay, so that is the ground truth here. So now you should have a ground truth or you should have a reference data to compare with your result. You should have a result, or you should have a, what to say, you should have a reference data, and you should have the result. So if you have a reference data only, then you can compare. Okay, if you only have a reference data, then you should only compare it with your land use and land cover. So what we are going to do is that we are going to compare the result or our LULC classified image with the reference data or the ground. Okay, so the first thing we do have the result, we do have, because we have done that. Second thing is like the ground truth or the reference data. Okay, now you tell me what are the possibilities, or you can message in your chat what are the possibilities or how we can collect the reference data. How you can collect the reference data about the point or a region.
So
About
we
your,
can use 3PS and
sorry, sir. Can you please repeat?
we can collect by using GPS.
GPS. So the first option is like you can take GPS.
Yes, as well as mobile. We can able to
Sorry.
plot that long value and we can able to note the what type of vegetation. For example, agriculture means rice or maize. We can able to classify. We can note it out in the GPS as well as, and we also note on my note. We should
Right.
do on two times.
Yeah.
Simultaneously, because once we lost the data, that note will be help to do further analysis.
Yeah. Right. So what the crux he is telling about, you can use GPS devices and go for a ground survey, right? Right, Ajay? I think it was
Yes, yes,
Ajay.
and
Yeah.
also if the place is not able to, we can't go on means we can able to use Google Earth Pro.
Yeah. Yeah, so the first option what Ajay was mentioning about is using is a ground surveying method. Okay, you can go to your study area. You can go to your study area. You can take some necessary devices that you want, like you can take GPS so that you could take the location. Okay, so in that GPS handheld device itself, it will be having an option to record the location values or the spatial information like latitude and longitude. Apart from that, you could also include details such as what kind of a vegetation or like what kind of a land use is there, like whether if it is an agricultural area, whether if it is a built-up, whether if it is a water body, whether if it is an open land, whether if it is something else, whatever you want. So the crux is like you can go for a ground surveying and you can collect the data. Okay, then again, the second one, what he was mentioning about is that if that area is not accessible to you, not accessible in the sense like you are doing, like this is for your training purpose, and I am sitting here in Kerala, Trivandrum, and the study area that I have taken is a place in Andhra Pradesh. Okay, so what if for just an educational purposes. Like you are all sitting in different parts of the country, and we are all doing for a similar place like in Andhra Pradesh. Like it is not possible for all of us to come to Andhra Pradesh and take ground survey. So if the ground surveying option is not possible, then the next options available are using an existing data. Okay, using an existing data, but make sure that that existing data is correct. Okay, that existing data is correct. So using an existing data means, so usage of secondary data. Okay, so that secondary data could be anything. Okay, it is a accepted, already created land use and land cover map. Okay, it could be an accepted, already created land use and land cover map. It could be that one. For example, we say in that reference data, the secondary data could be an existing LULC map. Existing LULC map. It could be an existing one. Then what else? What else are the options available? What else? Hello?
Can you repeat once again what you are saying?
Sorry?
Can you repeat as it? Can you repeat once again?
First thing is like going to the ground and identifying what features are there. Second one is like using an existing data. Okay, so in that existing data, one option is using an already existing accepted correct LULC map. Okay, so then we can refer to that LULC map. So what are other options other than this LULC map? Using that LULC map, other than how we can collect a reference data.
Sir, by doing the analysis, like we can do before and after. Like if we are using for 2015, we can do simultaneously for 2020 by analyzing this existing LUC.
Yeah, that's like the comparison. But I'm asking about where can you collect the reference data?
Sir, right now we have open source data like.
Yeah, right. Very good. Like we have a lot of open source data available in the domain. Like first one is like all of you like which are free to use. Like open source in the sense like Google Maps are not open source, but we can take a reference on that. Okay, so like already available satellite images.
Like
Okay.
the years of Sentinel.
Yeah, Sentinel data is there and all are there. So we can use that data, satellite images. Apart from that, now you can use Google Earth. I hope you have heard about that
Google.
option, Google Earth. Google Earth or Google Earth Pro, whatever, like Google Earth you can use. And likewise, now there is something called as OpenStreetMaps.
Yes, sir. Yes, sir.
Yeah, OpenStreetMaps. So there are plenty of resources available. There is no need for you to go to the ground and collect data. But of course, it's the most what to say recommendable and most like corrected one. Like, but then also it is not possible if you are doing something. You can download the satellite image at the any part of the world, and you are trying to do it for a region in USA. But for going and collecting sample data from there or the reference data from there, it is not practically possible. So that you can use any other secondary data. So apart from these, there are something called as topo sheets. Have you heard about it? Have you heard about these terms, topo sheets? Some survey of India.
Yes, sir. Yes, sir. Yes, sir. Yes, sir.
Hello? I think Mr. Sulfikar, your mic is on. Okay, so there is something called a survey of India topo sheet. So all these data sets you can refer for your reference data. So collecting the reference data. Okay, So these are just the data sources which I want to mention you about. Okay, now today we are not going to going for any ground surveying or any other purposes, but we are going to collect some reference data from this one. So this one is a base map, and this base map is available in your QGIS. Okay, so there is an option called as web. Okay, so if you didn't find this right now, don't go for it. I will say you how to like you have to install another plugin. I will say about it. So just listen to it. Okay, don't worry or don't just try to do it right now. Okay, so what you want to do is that you can load the base map of that layer. So when you go to web and quick map services, there are a lot of plenty of providers here like OSM, OpenStreetMaps that I have already mentioned. So these are the base map providers. So if you look at some of these, but it's not available in our region, but in many cases it is available. So as all of you know about these provider, Google, I'll now go for this one. So Google satellite I have taken. So now you can see there is a base map. Okay. Now just I am switching off this LULC and I'm switching on this ROI so that I can clearly understand where is my area. Unless if I am just going and collecting something from here, it will be hard for me to identify whether if it is inside my study area or not. Okay, so you can see now it is very clear that this is a water body. This is a built-up area. Okay, there are some patches here. It is vegetation. Then here it is an open land. Actually, it is also an agricultural region, but currently it is fallow. So yesterday we considered it as an open land. Okay. So likewise, we could identify the features from it. Okay. But what now we have told is like we visually look into each of these points and identify, okay, my this point is correct. Okay, my this point is correct. My this point is correct. I don't want to do it like that, but I want for the entire English, I want to understand like what is the overall accuracy of my classification. Okay, it will compare. Again, we'll be taking some samples from this study area, and that samples will be compared to the LULC image or the classified image, and the system will say you that, okay, from the given references you have taken, it is found out that your accuracy is 30%, or your accuracy is 50%, or your accuracy is 70 or 80 or 90, whatever it is. Okay, so that is we are going to work. So the first and the foremost task is creating two layers. Okay, creating two layers. First layer is the LULC. Okay, so we have already created. We have to we need two data. The first one is like what to say, the LULC. We need two things, LULC, and second one is like the reference data. Okay, so these two are needed for what to say, for identifying or to calculating the accuracy. So the first one we do already have, the LULC we do already have. Now we are going to create the reference data. Okay, so is it clear what we are going to do right now, everyone? Is it clear? Okay, I hope.
Yes, sir.
Yeah, I hope it is clear. So now what we are going to do is that we are going to create a file, and we are going to say the system that, okay, this portion is water body. Actually, the reference data, this portion is water body, this portion is built up, this portion is vegetation, this portion is what to say, like open land. So now we are going to do that. So for that, we are going to create a file. We are going to create a new file. So to create a new file, yesterday what we have done is like we have just loaded the pre-created files. Okay, the pre-created file. So now we are going to create. Let me check whether if it is recording. Yeah. So what now we are going to do is that we are going to create a file. Okay. So right now we are not going to create a raster file. We are going to create a vector file. Okay. Vector file means a shape file. This ROI, this ROI kind of thing. Yesterday I have just mentioned you about what actually raster and vector is. Okay. So now I am going to create a vector file. Okay. For that, what you have to do is that you go to layer. You are going to create a layer. So go to layer. Yesterday we worked on this add layer. Now we are going to create a layer. Okay. So go to layer, create a layer. Here, what you are going to do is that the second one, new shape file layer. So this is the vector file layer, new shape file layer. Okay. So go to layer, create a layer, new shape file layer. So once you click on this new shape file layer, a dialog box will be appearing. Okay. A dialog box will be appearing. So now in this dialog box, the first thing is like you have to give the file name and location. You can simply type the file name here, but the problem is it will be saved in the default folder of this QGIS directory, but it is not in the folder. You cannot, that will be not saved in your easily accessible location. So what you can do is that you can simply click on this browse so that it will lead you to the yesterday's workspace. So here you can create, if you want, you can create a new folder and let's say reference. So we are going to create a reference data. So creating a reference data. So double click. So open that and now you can give the name. Let's say I'm giving reference file. Okay. Now here you can see the file format is .shp. I think yesterday, you remember yesterday while loading that ROI, you have loaded that same file extension SHP. Okay. So you have given the name. Now you can see the location is defined here. So what you have to do is that you have to first go to layer, create a layer, create a new shapefile layer. In this, you should browse and give the name and the location. Okay. Keep the next one file encoding type as such. Now here you have to drop down in the geometry type. You have to click for a drop down. Okay. Now it is asking what kind of a shapefile you want, whether if it is a point, multi-point, line string or polygon. So basically, there are in this vector data type, there are three different classifications. One is point, one is line, one is polygon. So what actually this point is, points are used to represent points or just simply the locations on the earth surface. For example, the locations of electric post in your district. Okay, the locations of electric post in your city. So that is just simply a location. Okay, so then where do we use this line? The line is used to represent linear features. For example, if you want to represent the roads in your city, then you cannot simply use points. You should use line. Then say if you want to represent the streams or the rivers in your city, you cannot simply use a point. You should use line. Okay. Then where will you use polygon? If you want to represent a feature with an area. Okay. For example, if you want to represent the administrative boundaries or the ward boundaries in your city or in your district. Okay. The ward boundaries or the panchayat boundaries or the corporation boundaries of your district. So then you have to use a polygon. So that means if you want to represent an area, a feature has an area, then you will go for polygon. If you want to represent a feature with a length, only length but not area, then you will go for line. But here, if you want to just only mention a location, then you will go for point. Okay, right now here we will go for polygon. So that why polygon? Because yesterday, like in ROI, we have just a polygon can select a number of pixels from that. So that uh, it will be easier for us so that it will collect a number of polygons rather than a single cell. So we will go for polygon. So we have gone for polygon. Now, here there is something called as a projection. Uh, uh, so it's like you just click on this. Actually, projection is actually Earth is a three-dimensional object. Okay, Earth is a three-dimensional object in its real world. Earth is a three-dimensional object. But here you see, we are plotting that three-dimensional object on a flat surface. So it is flat. So that means there might be some, so not there might be, there is some mathematical approximations. Okay, you just think of a football. Okay, now that's a three-dimensional object. You just cut it into pieces and you try to make it flat. It will never be flat as like a paper. It will not be. There might be some kind of undulations. There might be some kind of heights. There might be some kind of depressions. So here, but you cannot see any kind of a depressions or heights. Why? Because it's a mathematical approximation is being done on this map and it is being flattened. So while creating a new file also, we have to do that calculation. So that's this one. Just don't, if you are new to this concept, just don't confuse. What you have to do is that simply click on this select CRS and you just select, or in this filter, you just give the number 32643. Okay, 32643. This is a projection. Might be geography, geology, and earth science students might be knowing about these concepts and these projections. But rest of the others don't think about it. Just give 32643, which will select you. Here you can see it's been covered entire world. So when you click on this one, you could see it's been placed nearby in the Indian region. Okay, so click OK. So the number is 32643. Okay, 32643. So if you want, you can write down the number so that you can use it. So the number is 32643. So then give OK. Okay, so now you can see it is selected. Okay, now you have to create a field. A field means this is a shapefile. There might be some associated data or associated information we have to load it with. For example, last time while giving an example about the location of the electric post. Okay, location about the electric post. So the location will only give you the latitude and longitude, but this field will give you the details about the post, like the number of the post, what is the number of that post, how many connections have been, or something like that, whatever it is. Okay, now if you go to the polygons, the polygon will give you that area and the extent, but the rest of the fields gives you the details, like what is the name of the ward, what is the area of the ward, how many people are living in that ward, what is how many rivers are flowing through it, what is the number of cattle or animals that are rearing in that ward. So all these details comes in the field. So this field will act as an Excel like format. Okay, so here why this field is important, because now we are going to compare this reference data with the LULs. Okay, with the reference data with LULs. Now, yesterday while creating this LULC, I've already told you this name, water body, vegetation, built up, open land. These names are for the user understanding, and this 1, 2, 3, 4 is for your system understanding. Clear? So now, while creating a reference data, we cannot simply give water body, vegetation and all. We can give the corresponding number. Okay, for example, I am creating a polygon here and I should give the corresponding real world feature number to that field, so that this location will be compared in the LULC and in the reference data. Clear? And it will check whether both of the numbers are same in this region. If it is yes, then it will give it will say that okay, your accuracy is right. But if it is not, it will see that your accuracy is error. Sorry, your classification have some errors. So what you have to do, the name is MCID. Why MCID? Because this is for our understanding. You can give any name actually, but for my understanding, I'm giving it as MCID. Why? Because I'm giving the same numbers also here. So it is macro class ID. Okay, then type has to be, we are going to give number, so you have to give integer. Okay, now after this, you can simply click add field to list. That means then only this given details will be added. So now you can see there is a new field added. So you can give OK. Okay. So here you can see the reference file is added here. This is a previous one. Let me remove that. Okay, this is the new one that we have currently created, a reference file. Okay, so now what we are going to do is that we are going to collect samples. Yesterday from ROI, how do we collected the samples? Similarly, we'll collect samples. Okay, so how we can draw that? You cannot simply go to ROI because this is not the LULC creation, but another file. So what we are going to do is that simply click on it and go to right click. Okay, right click here, you can see there is something called as toggle editing. Okay, toggle editing. Apart from that, here you can see there is a panel. Okay, so once you can click on, either you can click on this panel or else you can right click and go to toggle edit. So once you click on toggle edit, now you can see these are all inactive. Once you click on toggle edit, you see these are all active. Okay, so either you can simply click on here, it will start editing, or else you can simply right click and toggle edit, it will also work. Okay, so right now what I'm going to do is that right click, toggle edit, and here you can see still your mouse pointer is in a hand like manner so that you can pan. What you have to do is that you can see an option here like add a polygon feature. Okay, so what we are going to do is that yesterday we have created an ROA polygon. Similarly, we are going to create a new polygon. So when you click on that, the mouse pointer will change. Okay, now what we are going to do, we are going to draw a polygon. Then right click. So it will ask for an ID. You can simply just give any number. Even you can what you can keep it a leave left. Okay. So now whatever important point is like MCID. Okay. Now you forget about this LULC. Look at your base map and understand what feature is here. What feature is here is water body. Just think what is your MCID for water body. MCID for water body is 1. So give 1. Okay. Now go to another place. Uh, that should not be in, that's need not to be in the similar order. Like first we'll take all the water bodies, then we'll take all the build-ups. That is not needed. What you have to do is that correspondingly give the numbers. Okay. For example, here, okay, I have came here. Actually, this is the vegetation. So again, then I have taken a polygon. So now what actually here it is vegetation. What is the ID of vegetation? If you forget, you can see it is here 2. Okay. Now I'll go for something else like, okay, we'll go for a build-up. Okay. So I've taken another polygon and the built-up ID is 3. Make sure don't go for 0, 3, 3, 0, nothing, just 3. What here shows. Okay. Then I'll go for some more build-ups. Okay. Then 3. So we are telling to the system or we are telling to the software that now I am collecting the reference data. In this reference data, you consider this area as MCID 3. That means built up. Yeah, that's what we are doing. Now, when you go here, you can see, okay, let me check whether I'm inside the RO. Yeah. Okay, so now another one, a built up. Okay, okay, 3. So likewise, you have to collect samples of different classes. Again, we'll go to vegetation. Vegetation is 2. Then again, we'll go for some, yeah, open land. Okay, open land is 4. Again, here also some open land 4. Open land score. Okay, that's fine. Now we will go for some water body. We have selected one among the water body. Now water body ID is 1. And here is also water body. I am telling the system that this is the reference data and here it is water body. Now this is an open land. Land is 4. Okay, so I think you understand the process. As like yesterday's session, I'm just demonstrate you the process. But while you are doing, you can collect more and more samples and more points so that your details will be much more accurate. Okay, so now I'm finishing it by now. So once you completed this, what you have to do is that come and click on this one. That means save it. Unless you saved, it will be lost. Then again, it is needed for you to do it once again. Okay, click on save layer. So it is saved. Now you have to go to Google Edit and again click on so that these, the mouse pointer will change or the editing will be completed. So once you click on Google Edit, now it is over so that you can click on this plugin, sorry, this hand tool, and you can add it. Okay, so what we have done right now is we are collecting the reference data. So for doing the accuracy assessment, we need two things. First one is for doing the accuracy assessment, we need two things. First one is LULC. We already have that. Second one is reference data. So that reference data we need to create. Now we have created that reference data from a base map. So that base map is already available in Google Earth, sorry, in QGIS. So we have used that base map and we have created a new file and we have collected the details from the real world. Like we set in the file or we set to the system that this region actually have water body, but water body, if we define water body, the system won't understand. So that we give the macro class ID itself there. That's okay system. While you are comparing the reference data and LULC, consider this region has the MCID 1. What you have to do means what the system has to do is that the system will consider this region and check whether the reference data and the LULC classified data have the macro class ID same here. If it is same, it will give okay, it is this portion is correct. If it is not correct, that means if it is for example, if I am creating a region here like a reference data here and I am giving a macro class ID 1, that means in reference data or I'm purposefully making a mistake, like I'm giving it here 1. So that means in actual world, even though it is a open land, I'm saying it as water body. So what system will understand is like in the reference data or in the real world, here there is a water body. But in your classified one, you classified it as an open land. That means in your reference data, the MCID is 1 and in your classified data the MCID is 4. So that means the classification at this portion is wrong, so that your accuracy will be comparatively lesser. Okay, so now we have created the reference data. Okay, now what we are going to do is that now we are going to calculate the accuracy. For then again, for calculating the accuracy, we need to go to SCP plugin. Now the first thing, like you could understand, while clipping all these things, what we have done is like we have gone for the pre-processing and all these things, but the pre-processing is completed. Then we have gone for the band processing for the classification. So the classification is completed. Now we are going for the post processing. Okay, so pre-processing was there, then processing was there, and after that post processing. Okay, now we'll go for the accuracy. Okay, now we will go for the accuracy. Now, once you click on the accuracy, make sure all these like the LULC is also loaded here. Okay, the LULC and reference file should be here, then only it will work. Here we are not going to do anything with the bands, like these bands. So it is, right now for this portion, it is not, the band sets are not needed. So don't worry about the bands loaded here. So for the accuracy, what we need is this LULC and this reference file. Okay. So once those files are loaded here, you can simply click on this refresh. Okay. What it is asking for, select the classification to access. Select the classification to access. So just click on the refresh so that all the layers, all the raster layers will be loaded here. You have to select from this which is your LULC file or the classified file. So the name is LULC. So I clicked on LULC, so it is selected. So next it is asking for select the reference vector or raster. It could be a vector or raster, but we created a vector. Select the reference vector. So again, refresh it. It is giving another details, all the vectors and rasters. Make sure your reference data is reference file. So give it. Now, the third one is important. It is asking from this vector, which field has to compare with this LULC? Which one is that? MCID. So now what will happen that the LULC already has a macro class, and that macro class will be considered or compared with the reference file, the MCID of the reference file. Okay. So do you want me to explain this step once more? Anyone? Yeah, I think it is clear. So
you can continue.
yeah. So select the classification to access. So here you select your classified file or your LULC. Second one will be your reference file. In that reference file, which field has to be compared? Sometimes uh, here you can see it's an ID and MCID. Okay, before that I'll just show you what actually this looks like. So reference file, right click, open attribute table. In that attribute table, now here you can see the MCID. So it will be like if you want to add some more details about this region, okay, this some description. Here you can add another column and you can give us, okay, this is a man-made pond, or this is a house of this man, or it has two members. So likewise, you can add all these details, but so it might be having n number of columns. It can have n number of columns. So that's why here it is asking you which column do I need to compare. So you need to compare MCID. Okay. So now what I'm going to do is run. Similar process. You click on run. Once you click on run, it will ask for a place to save. Let's say accuracy assessment. Okay, so now here you can see. So even though you can see that this is a TIFF file, that means a raster data, we are not concerned about this TIFF file, because what accuracy means to us is like, rather than seeing these images, accuracy means a value for us. Like your accuracy, your assessment accuracy is 30%, your assessment accuracy is 20%. So that value is needed. So there will also be a report, an Excel report will also be saved in this rather than this TIFF. And we more of the time we use that Excel or that the CSV file. Okay. So once you run, click on save. You complete. So what actually the system is doing, like what we have mentioned, the system will take the MCID from the LULC, and also it will take the MCID from the reference data, and it will compare both. Just a minute. Yeah, actually, the samples taken were not enough, I think. So that's why we haven't got the accuracy value here, overall accuracy. So, but here you can see, so this is the error matrix. So in the error matrix, I'll do it once more and we'll get that value. But here you can see this is the error matrix. So this is the report of that accuracy. So the error matrix, what actually you have to understand this error matrix first. So what actually this error matrix means is that, so this V classified is the classified land use data or the file, this one, this file. Yeah, this LULC file that we have classified. So 1, 2, 3, 4. Okay, so these are 1, 2, 3, 4. And so this is the reference data where 1, 2, 3, 4. Here you can see the 4 one. I think there are no enough samples. So that's why it has uh, ended up in some kind of errors. Okay, so this one is a classified image. This one is the reference image. So totally 2719 pixels were taken for reference. Okay, taken for reference. That means 2719 pixels were taken for consideration or were taken as reference data in water body, among which one one. That means all of 2719 were classified under or combined. In both the cases, they are similar. That means for the water body, it is correct. Okay, so now you can go to the second one. Here, two. So it should go like a diagonal. Okay, it should go diagonally. It should go diagonally. Okay, so here what happened is like 2719 were taken totally, among which 2719 were comes under the correct one. So now the second one is vegetation. So how many pixels total? It was only 9 pixels were taken for vegetation. In that, sorry, in that 8 pixels were classified under 2 in both the cases, and 1 was classified wrong. Okay, that means in the reference data, it is like a water body, but in classified data, it was built up. So that was the error. So here you can see just only 1 pixel. So yeah, just only 1 pixel were taken. So that is not enough number. So that's why it was ended up like we are not getting any accuracy. Okay. So here 48 pixels were taken, among which 35 were done under 3 and 13 were wrongly classified. Okay, so that's why we are getting a lot of accuracy results were not predicted. So we'll do it once more. Why? Because it has to be taken much more number. Okay, we'll remove this one. Okay. So this is how actually, I hope you understand the process, right? So what I will do is that I will load another reference layer, which I have just used, created yesterday. Yeah, I think this is the one that we have now used. Yeah, this is the one, right? We have used. Yeah, this one actually, yeah, this one actually I have done yesterday just for checking the plugin compatibility and all. Okay, so this is another one. Is similarly, I have taken some samples and values out here. Now we'll again go for SCP, uh, post processing and accuracy. Now again, you can go to, just a minute. So now you can again select LULC, and here it's the same file. Just no problem. We'll take some samples once again. This file, that's data is the one. And I will try with this one. So for it's not updated, sorry. Reference data, LULC, and MCID. Let me check with this. It is again doing the mail. Do it once more. Okay. Yeah. So now you can see you got an overall accuracy of 92%. Here you can see in the metrics. So here you can see it has a plenty of samples here and there. Like here I have taken, here I have taken, here I have taken, here. Okay, so you should also, at least the system should compare. It should have enough number of samples. So that's needed. Okay, enough number of samples are needed. So while you are doing, you just select a pretty nice number of reference data samples. Okay, so then we'll could compare. Okay, so this is our result. So like here you can see, out of 1618 pixels I have taken, 1603 were correctly classified and 15 were classified wrong. Okay, here for the second one, out of 237 pixels I have taken for the comparison, here this one, it comes under 2 and 2. So that those are correctly classified. 237 completely correctly classified. Now here for the third MCID or third class, 92 pixels were taken for the classification. Here you can see comes under, sorry, 90 pixels were correctly classified in both the layers, but 2 were wrongly classified. So in the fourth one, that means open land, I've taken 122, but among which in the fourth one, 122 were correctly classified. Okay, so here you can see the overall accuracy is 92%, and the kappa has classification coefficient. So that kappa coefficient is ranging from -1 to +1, where sorry, nearby +1. That means greater than 0.8. That means greater than 0.8 shows it's a good classification. So the overall accuracy, the acceptable overall accuracy is more than 85%. Okay, if your overall accuracy is showing less than 85% or less than 80%, normally what the system suggests, or normally what the people users suggest is to do the classification again. Okay, so you'll get the report right here itself. At the same time, you'll also get it as a CSV report. Here you can see, yeah, here you can see all these, and you can have a look at these classification parameters like the overall accuracy and the kappa coefficient. Okay, this is how you will be doing the accuracy assessment. Okay, so I think you got a general idea, but it's by if you do that, then only you will get an understanding. So like yesterday, all of you please try this with the help of
Try to do that thing, sir.
us.
So can you open that Excel?
Excel, yeah, sure. Yeah.
So that what about the area? Like it's a total area in hectare or square kilometer?
So we're actually
So fifth classification, that area.
area. Also, these are in square meters, I think. Yeah.
Actually, when we are doing this accuracy assessment, it will do automatically, right?
Sorry,
So
can you
actually,
please say a bit louder? I can't hear it.
so when we are doing accuracy assessment,
Ah,
that area also it will do automatically, right?
yeah, automatically.
Why I am asking, because like whether the area when you are doing automatically, it will be correct or wrong.
It will be correct. It will be correct. Why? Because see, so these are all spatially referenced one. That means these are all spatially referenced in a sense means it has its correct and proper geographic location. So once you have the correct and proper geographic location, and you know these are all pixels. Each pixel have a definite length and a breadth. Okay. Each look at this pixel, it's a square. So each pixel have a definite area. Okay. So likewise, the collection of this will be having a combined area. So that area will be definitely correct. Why? Because it is spatially referenced. So that is the importance of GIS. Why? Because it has a location reference and it has an area. The area will be definitely right. Also, without referring to this one, you can simply calculate the area from here itself, like SCP, post processing. You can go for the classification report. So once you click on the classification report, you could select the classification type from here. Let's go for LULC. So and you get run. Let's say a report. So it's in the area in the meter square. Here you can see in square meters. Okay. So it's available here, and also you could use that in the report. That means you could also see that in the report, so that if you want any conversions, you can do the conversions here itself. Also, it will give you the percentage, and also it will give you the number of pixels.
Yes, sir. Yes, sir.
Okay. Are you clear about it?
Yes,
Yesterday
sir.
also someone asked
Yes,
me about, I hope Ajay it is clear.
yes, yes, sir.
Yes. Okay. So yesterday also someone asked me about the classific area of calculation. It's simple. Like you have to go to the SCP plugin anywhere, and then you can actually. Yesterday the clipping and these all these processes were pre-processing, and after that the classification was the process, and after that this is post processing. So you can go to post processing. We have done accuracy assessment, and after that you need a classification report. So you can simply click on this and you can select your LULC and you can give a run, so that you will get the report. In this you can see it is an area in meter squares. So rest you can what in whatever units you want you can convert. Okay, so that's it about the accuracy assessment. I hope this is clear to everyone. If you yesterday, so any doubts regarding yesterday's session? I think it's 11:30. It's time for your next session. So before that, we'll clarify the doubts. Saurabh sir, is it okay if I take
Sir,
150?
Yes, yes, yes.
Yeah, yeah, Ajay, please.
I want to share.
Sorry.
Confirm.
So I will tell her that you
Can
want to
you
Yes, yes.
Hello. No, you can ask your doubts or you can post it in the chat. Anyone?
Yes, sir.
Anyone
Actually,
have any doubt?
can you say about the data management regarding special data, like how you are managing the data? Because right now we are using the different kind of data. Can you have any
Ajay,
we have to
Ajay,
use this type of data? Yes,
Ajay,
sir.
actually,
Yes, sir.
it's not audible. Can you now? It is loud. Can you speak right like now?
Yes, sir. Yes, 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 yes. Sorry for that. Because of connection is very poor here. It's
Or
audible
else
now?
you could post the question in the chat. Actually, it's not audible.
It's audible now?
Yeah, it's right now. It's audible.
Sir, actually, right now I have a general question. Actually, can you see about data management? Like Right now we are handling with so many kind of data, like
Right now,
follow the after, yeah, like data management of the geospatial.
data management in the sense, I'm not, I didn't get the question.
Like sir, actually, when we are using so many data, like right now we are using area and classification, and we have false color composite. We have so many data. After completing this work, do some other work. So like project.
Okay,
So we have
okay. That means you need to differentiate each and everything, so that how do you will manage that one, right?
yes.
Yeah.
Since we are coming back after one, so we have to access the same thing.
See, actually, yeah, actually, in QGIS, it's always preferable to create like a folder. That's it. And after that, all the works are being in that folder. So right now, here you can see in my screen, I have a number of folders. Okay, accuracy assessment, classified image clip data, dataset project. Actually, this kind of a folder creation is not actually recommendable. Okay, so what we actually do is that we will create a folder for a project. So let's say if I could create a project, let's say rather than you, let's say I'm doing this for animal husbandry, a project, and after that, what all the files that we are creating for this animal husbandry, we'll save it here. Okay, we'll save it here. Okay, then another thing is like if you open this, that the classified, let's say the data set, here you can see these are all not generally openable in the Explorer. Okay, so that it's only available and it's only been clearly accessible through the software itself. Okay, so once you are creating multiple folders, it is also not recommended. So why? Because if you could only access it through the Explorer, then only it is creating the folders makes sense. Unless if it is only accessible through the software, then creating. Hello. Someone's mic is on. Hello. Okay, so if it is only accessible through the software, then it is better to keep it inside a single folder and it access only through the software. So while you are, this is about the case of QGIS, but while, so that another important thing is that if you want to share that entire work to someone, you could only just compress that folder and you can share it. Okay, so that is the first thing. So this is the case of QGIS, but in some other softwares there is some kind of a database management system, and there is some kind of a GDB kind of a stuff in which all the data will be inside that folder only. But for QGIS, what we often do is like creating this kind of a folder, a single folder. But why? Here I have created a number of folders because it's just a demonstration so that you could also understand. In my understanding, I was thinking like this is an introduction for many of the people, so that just creating all these stuffs into a single folder will make some confusion. So that's why I have created a number of folders, but it is not recommended. You could create a single folder and you could include all the data here, but not access it through here, but only through the software. So it will be easy for you to understand what actually it is and what it is. Also, make sure that you save this project so that you can simply click on that project and you will get all the data ready as such whenever you last left. Okay.
Sir, and one more thing, like yesterday we are discussing about the teams.
Discussed about the
Plugins.
plugins.
Yeah. Actually,
I think your voice is breaking. Can you
like we have
please
any other
It's audible now?
Yeah, now it's audible.
So actually, yesterday you are just teaching us SCP, like it's a plugins. Like in right now we are doing a assessment. Can you? It is possible to make a list of plugins we can use for facial in the QIGIS, so we can able to install our and we can able to explore them. It is only one we can right now we are exploring. It is any
Yeah.
other
See,
thing?
yeah, that's a good question. But giving a list of plugins means
Actually, one more thing. Like one more thing.
yeah.
Sorry, like for SCP, we are using one code.
Hello.
I'm audible now.
Yeah, but it is breaking, Ajay.
For SCP, we are using some code in OS shell. So likewise, we are using any plugins. If I'm using trend, it's one code in one more code in like it's not working for me. But what is the thing I don't know. But likewise, if we are using any other plugins, we need code for to run that in our system. It is necessary.
Yeah. Yeah, the two questions. First one is about the list of plugins. So the list of plugins means we cannot say it like that. Now you look at my screen. These are the plugins available in QGIS. Okay, so look at this. These are the plugins available in QGIS. So basically, it's based on our work. If you are going to do a land use and land cover classification, you will be using our SCP plugin. Okay, if you are going to do something with the hydrology, then you will get some other plugin. So likewise, it's based on your work. So at the time of your work, you can simply search over the internet. Okay, plugin
If
for
it is possible, can you make some Word or PDF for us? It will be very useful. We can
for the
able
plugin
to yeah
of the list of the
like
plugins.
like right now yes whatever like for ideology or any other like
Yeah,
we
yeah.
have anything.
Yeah, right now I have nothing with me, but I'll search it and I'll definitely send you because like we were using a lot of plugins. Like this is for the volume calculation, this is for SRTM data downloading, then this is for some kind of hotspot analysis, and this is for flood monitoring and all. So likewise, there is plenty, but there is no such document available. Let me check over the internet and I'll let you know. But if you are working on a specific domain, then you can simply search over the internet. The advantage is like QGIS is an open source software. So that means everyone or every developer can create a tool. So that is an advantage. At the same time, it's a disadvantage. That means plenty of plugins are available. Sometimes once they will only create a plugin, but what's the specialty of QGIS is it is just updating day by day, or it is updating month by month. Updating in the sense not means not the new version, but the tools and all. So sometimes once one will be creating a plugin and he will just post to the repository and he leave. He will not update it or anything. So what a non-developer user when he installs it, then he might be encountering a problem. Okay, so what happened for that plugins list is like you can just go to the internet and okay, I want to do a hydrology, let's say watershed delineation. Plugin for watershed
Not like that.
delineation.
Actually, what is a problem? What is the problem? It's a new environment we are using QAGs. Like we have to use the code. Okay, like SCP. For that we have to run. So likewise,
Yeah,
we are
yeah.
using ideology.
But that
We have
point
used. We have, or it is not necessary. I'm asking that. I need to clarify that thing also.
yeah, that to that I'm coming. So the thing is like, so what the error that you have encountered is because SCP has been upgraded. Okay, SCP has been upgraded, plugin has upgraded, and the QGIS version is a newer one. So that means both of them have a compatibility issue. So that's why we have to run that code. The Skylit package of the Python is not updated. So that's why we have to run the code. For every plugin, it is not necessary. So again, when you encounter, again, if you again, if you encounter in any of the plugins, there's a plenty of resources available. You could just search over the internet. That's it. See, like QGIS is working all over an open source platform. So that means everything is working on over the internet and everything is available over internet. So don't get confused or don't get tensed. If you find any of the difficulty like an error message, just copy the error message and you can just simply post it over the internet and you will get a plenty of solutions. Okay, so the main issue regarding this running this code was like SCP plugin is having is a specific version and QGIS was upgraded and it was a newer version. So there might be some compatibility issues regarding the Python. So the Python is basically the most prominent language using in this geospatial domain. So there is some Python compatibility issues. So we need to download some packages. So that's what the code does. So again, if you are using some other plugin, okay, some other plugin, and you find same, if something happens, there will be a message. So you can simply copy that message and you can just post it over the internet and you will definitely get the resource and the result. Okay, so don't get confused about it.
Final question. Don't. I have one more question also.
Yeah, please.
Actually, right now we are using with Landsat. Like it is possible to do. It is possible to increase the resolution in QGIS.
Ajay, the data is not Landsat. This is Sentinel. Okay.
Yeah, Sentinel. Like it is possible to do upscale. Like
upscale in a sense, you mean you need much more spatial resolution data.
yeah.
Yeah, actually, the Sentinel is the
The 10
highest,
meter resolution.
yeah,
Yeah,
Sentinel is the highest resolution available for public domain. Rest is paid. Data is available, sub-meter level resolution data is available, but it is not free, open access. We have to pay for that.
Okay, sir. Okay.
Data is available, even 2.5 centimeter resolution data is available, but we have to pay for it.
Okay, sir. For example, like we have 30 meter resolution. If you want to transfer 10 meter means it is possible.
Sorry?
We have a 30 meter resolution image. It is possible to transfer into 10 meter resolution.
No. It's the what the feature of the camera. It's the feature of the camera. We cannot if I have taken a photograph in my camera and I'm transferring it to you, you cannot increase the resolution. You can do some kind of AI enhancements and all, but you cannot increase the resolution. Okay, so that's it.
Yes. Okay, sir. Okay, sir. Thank you so much.
Okay, so there is another question I have discussed with you about the classification of all type of crop in single class called agriculture. Can you please explain with an example? So if you want to classify see, like if you want to classify all the crops, I think Devasmita, right? Devasmita, actually, I think, right, you want these regions and these agriculture regions to be in a single class, right? Hello? Yes, okay. So actually, this is current fallow. That means this region is a current fallow land. What happens is like it is harvested and it is set to free. But here you can see, here it is a crop. Okay, here it is a crop. Here it is a crop. So that means this is multiple crops. So if you want to classify an entire agricultural land, not as an open land, and but consider
Hello?
these.
हो गई जांच
Hello, Saurabh sir, your mic is on.
ठीक है वो दे दिया सीवी वहाँ पे एचआर को हाँ ठीक, ग्राउंड फ्लोर पे बैठते हैं वो.
Hello, Saurabh sir. Okay. So like if you want to classify these two into a single one, you don't need to create two classes. So like in ROI, sorry, SCP, let's go to processing. Sorry, shoot plugin. Yeah. So while you are doing for training input, here you can see we have taken open land and vegetation as two classes. Okay. Now what you have to do is that no need to create two different classes. You can simply create agriculture as a class and you can select samples from, let's say, here, and you can save it. So don't look at this point. This is randomly I'm creating. So just you can click here, save. You can simply click here and save. Okay. So what happens will be that the system will be considering this reflectance and this reflectance under agriculture. So that this portion and this portion, that means the reflectance with this color and this color will be treated as agriculture, so that you will be getting this entire area as an agriculture rather than these two kind of a classification. Like here it is an open land, like something like a what this color is, whatever it is, a pink or uh, orange, light orange and green, it will be entirely green. Okay. So if you don't want a multiple class, what you have to do is that you can include which all classes you want as a single one. You take the samples from both that classes as a single one, so that you will get the get as a single class. Okay. Is that what you meant, Devasmita? Okay. Okay. So I suggest you to do this as such. Okay. You do one thing. You just load it once more, like the satellite image, and you start doing this once again, like as your like your what is your classes you need, like build up, agriculture, then vegetation, bare soil, then water body, like you do once, and you just do a classification. And again, when you find any problem, you just contact us. Definitely, we'll help you and we'll solve. Okay. Yeah, sure. You just try it and you can. This is not for this 5 days. Actually, this group will be active every time, so you can post it, and or else you can contact us. Okay. So any other, sir? This, sir, will this YouTube playlist available for us in future? If not, in that case, which can we get some PDF or some other document which can give the details of manuals? And get it. Okay. So you can just go and type QGIS. You can click here installation guide and you can get training manual. If you want a manual or a guide like this, you can simply click here and you will get what's his name? Sulfikar Ahmad Laskar. Yeah. Sulfikar, you can just simply go to QGIS website and you will get a plenty of resources. And about this playlist, I think you need to check with Saurabh sir. Okay. So anything else?
So now I think I will share the recording with you all.
Yeah.
One more question, sir. We can download the images from the SCP plugin too. I don't think so. Maybe Anish can clear.
Yeah. So actually in SCP, there is an option called as download data products. Okay. But in most of the times, if you are checking for some kind of freely available data like Sentinel, and you could go for like click here. Yesterday we have told you about like we'll do this. Yeah, so this area I have selected. You could simply click and you can see like these are the what to say, the extent. Okay, now you can select the bands here. Okay, you can select the bands, which all bands you want. Like it has an different bands, but if you don't need all these bands, coaster aerosol, I am not working with it. 5, 6, 7, I am not working with it. 8, 9, 10, 11, 12, these are all I am not working it. So like if you want to select some specific images, like specific bands, you can click like this and you can go for run. uh, just a minute. Yeah. Just a minute. Yeah, actually, it needs the login details. Sorry. So you need to create an account in it. So I think I'll show you how to download it from here. So you can simply type like Copernicus Open Access Hub. So this is the place where you can download data about Sentinel. Just a minute, let it load. Actually, this is not the one. Uh, Actually, I don't know why. Actually, this is the place where we are normally downloading the Sentinel data, but sometimes it's yeah. So here, once you go here, so go to skyhubcopernicus.eu. Okay, you can simply type this in the yeah. This is our internet, and you can go to Open Hub. Click here. So here you can go to Sentinel data. So once you are in this point, you can go to Sentinel 2. Okay. So then, yeah, level 2 products. Yeah. So it's here. So here you need to go for a login where you need to create an account with your email and other details. And after that, you can not this one. Okay. So you should create an account, and after that you can download the data from here. Okay. So you can go to any area you want, like India, anywhere you want, and you can simply download it. So, or else once you create a login detail from here, you can go to this plugin. Okay, you can go to this plugin and you can give the like username and password here, like Sentinel-2. You are here your username and here your password, and then if you go for the search, you can simply download the data. Okay, so you can download it from here itself, or else you can simply create a login here and you can download it from here itself. Okay. I have tried this process and this site, but still unable. Have you created a login? Only download will be available for once you created an account. Oh, still you are facing the problem? So what is the problem? Actually, the satellite image that I have sent you, no, that I have just downloaded 2 days before from Copernicus. Okay. So you can share me a screenshot. What is the problem you are facing? Else I'll guide you or I'll give you the steps. Okay. So next time you are trying, like after the class or sometime, you can send me what's the problem you face. Okay. So I think Sarabja will finish. Will
Yes, yes,
okay.
yes.
Okay. Okay, thank you all. So I think my sessions are completed by this. So please try about that LULC classification, accuracy assessment and all. And try to do it a number of times so that you will be getting a very good and clear hands-on experience and you can do it by your own. At the same time, the group will be active forever. So you have any doubts, you can post it out there, or if you people would like to call us, you can call anytime, no problem. Okay. So thank you. Please utilize it and have a good day and all the best. Okay. Thank you.
Okay, great, Anish. So we will have a 10-minute break, and then we will start one short lecture of around half an hour, continuing our EIA fundamentals and other thing. So please be here, or you can join after 10 minutes also.